Welcome everyone. This is Eli Sagor from the St. Paul campus, Green Hall. I'm very happy to introduce our speaker today, Mark Nelson with the U.S. Forest Service. For today's presentation, I'll talk a bit about his content in a moment. Mark is with the FIA unit with the Forest Service, and he's going to be talking today about habitat, about trends and conditions related to our forests and how those forests relate to wildlife habitat conditions. This is I think it's going to be a terrific presentation in its own right, but it's an important, it's got an important connection to an event that we're doing in October 10th and 11th up in Grand Rapids. We'll be hosting a major event. A whole number of organizations are involved. The Sustainable Forest Education Cooperative is sort of coordinating along with many other partners. It's going to be at Timber Lake Lodge, and it's focused on exploring opportunities to improve wildlife habitat outcomes of our forest management activities. We don't have time in that one-day event to present everything we'd like to present, and so we're using this webinar to go a little bit deeper into what we see as really the core content supporting that October event, and we're giving Mark an hour to go deep again on some of the numbers, what FIA can tell us about the condition of our forests and how those conditions relate to wildlife habitat conditions. Mark will be talking about a couple of different forest types. I'll let him explain all of that. But I wanted to mention that we are doing that recording. We're going to encourage everyone that attends in October to watch this recording before they come. And I think with that, I'll hand the floor to Mark. So again, Mark Nelson with the Forest Service. You're on.
Well, the room changed.
Thank you, Eli. Welcome.
The sign is downstairs.
Right. Have a seat, and welcome to those of you online. It's my pleasure to have this conversation with you today. I refer to it as a conversation because it's not a lecture. This is not the end of an analysis, but it's an ongoing process. So even though we have a longer period of time now than we will in Grand Rapids, we're still leaving a lot of questions unasked and unanswered. It's my pleasure to speak with you today on behalf of the great work being conducted by an analysis team within the Minnesota Forest Habitat Collaborative. We have representatives from Minnesota DNR, the Nature Conservancy, Forest Service, that's me, the University of Minnesota, both on Twin Cities and Duluth campuses, as well as with NRRI and with the Wildlife Management Institute. So the members of this team have contributed much to the types of questions that we're pursuing today, and I give them credit for that. Any misstatements or errors that are made, that'll be on me. That'll be my fault as presenter. But it's my honor and privilege to speak on behalf of this team today. Eli connected us to the future with the forthcoming event at Grand Rapids. I'm also connecting us to the previous webinar presented just last month by Jody Provost of Minnesota DNR, and I'll draw upon some of the framework that Jody has presented. If you haven't seen that webinar, you can see that one online as well. The URL is posted below. So please take a look at that to learn more details about wildlife habitat relationships and specific forest management practices that can affect those habitats. First, let's pause a moment and ask the question, what is habitat? There are many definitions or understandings of this term. One that I like is the resources and conditions present in an area that produce occupancy, including survival and reproduction by a given organism. This definition is from Hall et al., 1997. Note, by a given organism implies that habitat has meaning only relative to a particular wildlife species, of an individual animal or bird or so on. That's a more traditional biological use of the term, but oftentimes in forest management practices, we use a more generalized meaning or definition of this term, such as in coarse scale conservation. If we maintain a variety of forest conditions, of composition, of structure, of pattern, then we will in effect be providing habitats for many individual species. So during our talk today, keep those two contexts in mind. Sometimes habitat refers to specific needs for a specific animal. Other times we use it more broadly to talk about management types of opportunities. Jody talked about habitat needs for both game and non-game forest-associated wildlife species in Minnesota. And she discussed some of the components or attributes of forests that affect the quality of habitat, including forest structure, such as the size of trees or the successional or structural stage that is affected by stand age, forest composition, such as tree species or species groups or forest types, habitat features, specific features like individual trees that have cavities that provide nest sites or resting or roost sites, and metrics of landscape patterns. What is the arrangement of these forest patches? How big are they? What are they next to? Are you in the interior or near the edge of those forests? So Jody's talk emphasized opportunities to harvest for habitat and showed us how some of these management practices are intended to mimic natural disturbance. Since I've talked quite a bit about harvesting and the timber industry, let's just put it a couple slides in to look at some recent trends so we know the context in Minnesota. What is it that we're talking about? Timber product output is a product line of information that FIA produces based on a survey of individual mill owners, asking how much wood they process, where do they get it, by species and size, and so on. And so these estimates show some trends in roundwood production in million cubic feet for different sectors of the forest inventory. And it reveals that following this peak in the late 1990s and early 2000s, there's been a fairly substantial decrease in this roundwood production. But it varies among sectors. For example, in this central tier in green that I'm highlighting now, there's an increase in pulp mills, while in this purple band of the bars in the stack chart, we see decreases in the particle board mills. And we also see some emerging patterns, such as this orange bar, which represents industrial fuel wood, which you might think of as harvesting biomass for bioenergy. So although that does not yet comprise a large component of our forest resources or have a large effect on habitat, it looks like that's something to keep our eye on in the future. In addition to quantifying harvest in terms of volume, we can also look at acres cut. Using FIA data, which I'll describe in a bit more detail later, we can estimate the average annual acres of cutting, of harvest. This doesn't mean it's all clear cut, but it means that in composition. In other words, the tree species per se might not matter as much as the size, the arrangement of them, or the successional or structural stages, and consequently, wildlife species may be aligned with different successional or structural stages. Oftentimes, we assess the quality of habitat at the scale of an animal's home range, which is the area over which an animal regularly occupies or spends their time. But if we produce an assessment based on one animal and its home range size, that assessment may not apply to other animals because home range sizes could vary from a few acres for one species to tens of thousands of acres for another. So one important point here is your scale of analysis, your spatial scale, may have a large particular nest cavity site abundance within microsites.
Perfect.
Sounds like our sound is working well. I'm getting some feedback from the room, so we'll continue with that. But again, if you have any problems, submit comments via chat so we can make corrections. Jody pointed out the scaling effect with an example for this bird, the Goldenwinged Warbler, which every spring migrates north to occupy its breeding range, this red blob in this upper left panel. And so here we are in Minnesota, where up to half of all the golden-winged warblers global population are breeding each year. So it's especially important to us here. Then moving across these scales, they're looking at a matrix of landscapes of different patches of both forest and non-forest and selecting their home range within one or more of those landscapes or forest patches. In this case, young deciduous or perhaps a deciduous shrub forest, and then finally down to their site-specific selection of a nest site. Jody talked extensively about management opportunities at this landscape scale and also some site level features that could be addressed. During our talk today, we'll be focusing primarily on this range-wide scale. What can we say across an entire state, large portions of a state, or multiple states in a region? But we'll also touch briefly on some site-specific attributes, such as numbers of large trees or snags. Some species require multiple successional stages to meet their habitat needs. And Jody provided this example of American woodcock. In general, we refer to this as an early successional forest species, meaning that it's using young forests of about up to 20 years of age. But even within that range, woodcock requires different subsets of those age classes to meet their life history needs. Using the youngest forests for singing grounds or roosting, slightly older for feeding and for nesting and brood rearing. So it's important to identify specific classes of age or thematic classes, and that has an important effect on your analysis results as well. So let's carry this example a bit further. We'll step aside from habitat for a moment and look at some population trends for one forest-dependent wildlife species, the American woodcock, which is a migratory game bird. The U.S. Fish and Wildlife Service every year produces these reports, annual report on the population status, and this one is from 2016, the most recent report available. Within that report, there are a number of maps, figures, tables, and text. And I'm drawn to maps, so I was attracted by this one and started to look at some differences between neighboring states and provinces, Minnesota, Wisconsin, Michigan, and Ontario. What does it mean? The report says that Minnesota is the only state or province that had a significant increasing trend over this long time frame, 1968 to 2016. Wisconsin has a decrease, NS in parentheses, which means statistically not significant, and Michigan has a statistically significant decrease. Maps are driven by data, so if we scroll down to one of the tables, we can see that Minnesota's Singing Grounds Survey began in 1969 and it's been conducted every year since. For each state and each year, there are estimates of the average number of singing males per route, per Singing Ground Survey route across that entire state. So we can identify and analyze some trends, in this case illustrated by this trend line for the state of Minnesota, showing that very slight increasing trend in woodcock. Likewise, since this is conducted consistently across states, we can look at our neighbors in Wisconsin and see this slight decrease, and in Michigan, a more substantial decrease in the index of woodcock population. If we aggregate those three Western Great Lakes states together, we see that on average, there is a decreasing population. But we just saw previously that not all states are decreasing. So your area of interest or your spatial scale becomes very important in answering a question. So for managers, it is important to tier your analysis again to, in this case, the spatial scale of interest. So now let's return to the topic of our talk, habitat, and we'll look at how much habitat is available, the status or the amount and spatial distribution of that habitat, the trends, in other words, change, positive or negative or no change, and the temporal distribution, which means over what time frame, over which years are we assessing these changes. For this information, we rely heavily on our Forest Inventory and Analysis Program, or FIA, which is a research unit within the U.S. Department of Agriculture Forest Service, administered consistently across the nation in 4 research units, one of which is the Northern Research Station, which is located here in St. Paul behind me, just steps away from where I'm speaking now on the Twin Cities campus of the University of Minnesota. Our mission is to enhance the understanding of forest resources so that we can make wiser, more informed land management decisions. FIA is based on a statistical sample of plots distributed throughout each of the states. As are illustrated here on the right panel, we can see the locations of all the forested plots that are visited by field crews every 5 years. These field crews measure a number of attributes related to the conditions, such as the aspect or slope, physiographic class on each condition, as well as measuring individual trees, the species and diameter and other indicators of the status of those trees. From this wealth of data, we can produce a range of estimates of absolute numbers, or in this case, relative area of forest land across the state, here shown by counties. But we can also produce similar estimates by ecological regions or hydrologic unit codes or watersheds, congressional districts, and so on. FIA has been in continuous existence since the late 1930s. From historical publications and reports, we can look back in time and see what was the abundance of forest land in a state like Minnesota, shown here, decreasing from 19.5 million acres in the 30s and 40s down to 16.5 million acres in the 80s and 90s, and since increasing again up to its current state at around 17.5 million acres. You'll also see a second line here in red representing timberland, which is a subcategory of forest land. Timberland is productive forest land that's not reserved, meaning it's not in a wilderness area such as the Boundary Waters, Canoe Area Wilderness, Voyageurs National Park, and similar legal designations. I point this out because some of our historical estimates in FIA are constrained to timberland when we only collected plot data on timberland, excluding these reserved lands, for example. Our current inventory includes all forest land, so some results that, especially for historical trends, relate to timberland and some relate to all forest land. Because we collect this detailed information on tree species, diameter, and the conditions on those plots, including ownership, we can produce these types of estimates or cross tabulations and see that Aspen Birch group and Spruce Fir group are 2 of the most prevalent species groups or forest type groups in the state of Minnesota, both of which are more abundant on public land in the blue bars than on private land. In contrast, Oak Hickory group, Elm Ash Cottonwood, and others are more prevalent on private land than public land. Land ownership provides opportunities, but also some major challenges when we're trying to manage large areas for habitat across ownerships. How do we coordinate those things when the distribution of these forest compositional and structural attributes vary among ownerships, due in large part due to their management practices? We can look at trends for this compositional attribute of forest type group from 1977 through the current inventories and see, for example, that aspen birch and spruce fir appear to be declining over this multi-decade period. But if we look more carefully in just the most recent 10 or 15 years for spruce fir, now we see that there's an increasing trend. So this points out the importance of our temporal scale. If we were to use the entirety of this bar chart, we would show a decrease in spruce fir, but more recently, an increase in spruce fir. Like the Singing Ground Survey, FIA is conducted consistently across all the states in the United States, which allows for comparisons across states. Here we're looking at a structural attribute, stand size class. Stand size sounds like the area of a forest stand or patch, which is a bit misleading, and I apologize for that. What it really refers to as the size of the trees within a stand, the diameter class. Here shown as small diameter, medium, and large, which refers to seedling sapling, whole timber, and saw timber size classes respectively. We can see that in Minnesota, it's the small and medium diameter classes that are the most abundant. In contrast, Michigan and Wisconsin have that large diameter, the saw timber class being most abundant, with small diameter being least abundant. This provides us some context for comparisons such as that population comparison we made for the woodcock. We can look at trends in these diameter classes as well. Here for Minnesota on timberland, back from 1977 until current inventories, we see that there appears to be an increasing trend in this small diameter size class until the most recent inventory, where it levels off or may be decreasing. It's a bit hard to tell with so few data points here. We also see an increase in large diameter, but an apparent decrease since 1977 of this medium diameter class. Similarly, using stand age, we can look at trends in early successional or late successional forest. Starting here on the top with late successional, 100+ year stand age, there appears to be a gradual and persisting increase in the abundance of that age class. Down at the bottom here, this lower tier of these stacked bar charts, 0 to 20 year or early successional forest appears to be relatively flat across this time period. Now, to meet habitat needs, we don't consider these things in isolation, but we combine composition and structural attributes, as we've done for this example, looking at the abundance of young aspen forest, young being that early successional range of 0 to 20 years on timberland across the upper Great Lakes, with this red line showing an apparent increase in young aspen in the state of Minnesota, and the green and blue lines for Wisconsin and Michigan, respectively, showing the decrease in the abundance of those. So now we've looked at the population for woodcock and some habitat trends for habitat typically thought to serve woodcock's needs. If we overlay those two trend lines, the green being that habitat estimate from FIA, the red being the Singing Ground Survey line, we appear to see a correlation or relationship, some type of correspondence between these two in the state of Minnesota, as well as in the states of Wisconsin, decreases in both habitat and population over multiple decades, and the same for Michigan. In Jody's presentation last month, in June, she identified some major habitat categories, things that we need to maintain over the state of Minnesota to provide habitats for individual species. And these include early successional forest, late successional forest, long-lived conifers, which for our purposes today, we'll define as including white pine, white spruce, and northern white cedar, large diameter trees, snags and conifers and cavities, and metrics of landscape pattern. So let's take a look at these various large categories and see what's happening in the state. Early successional forest, we've already addressed relatively thoroughly using the woodcock and the golden-winged warbler as example, but there are other species, of course, associated with that end of the successional timeline. But we also need to include late successional forest in our management plans and in our analyses. We need to manage at both ends of this age spectrum to serve species such as the ovenbird and others shown on this slide. If we return back to that previous slide of average annual area of cutting, which is in the gray fill on the chart here, and compare that to this red line, which is aspen birch in the 0 to 20 year category, as we've seen in previous slides, there appears to be a slight increasing trend in that young aspen. That sounds like good news for early successional forest species. However, if we are to break up that 0 to 20 class into 4 5-year age groups, we see a different story. Let's begin with this youngest age class, 0 to 5 years, which is the green line, shows a pretty dramatic decrease, 200,000 acres over this decade and a half period. In contrast, the orange line represents the 16 to 20 year age class in the upper limit of that early successional forest, showing a nearly 300,000 acre increase. So the importance of this lesson is that the temporal scale and the thematic scale, we might call it, the level of detail or generalization we have in our categories can greatly impact the story that we're trying to tell. So the previous slide showed that early successional forest habitat might be doing well. This one suggests maybe we need to take a closer look. So let's do that. Let's look at the stand age distribution for Aspen Birch Group beginning in 2003. All of these analyses, again, are based on FIA data. We see that there are two peaks. One in the 0 to 5 year age class seems to be the most abundant in 2003, and the other in this 40 to 60 year range, a second peak. If we move forward in time just a bit to 2007, we see less of the 0 to 5 and now a shift to a 6 to 10 year old peak and a decrease in this 40 to 60 year range. Continuing forward through 2011 in the green and 2016 in this darker blue purple, we see a continued change or aging of peak forest from 0 to 5 here in 2003 out to 16 to 20 for the most recent inventory, and a corresponding decrease in this 40 to 60 year range. Note that we can also look out here further in the age class to identify something about older aspen. We don't typically think of aspen as an old growth species because there isn't much of it beyond 90 or 100 years of age. But within aspen, older trees, larger trees can be very important for some wildlife species. So here we see an apparent increasing trend in this blue line, which is the most recent inventory, is showing more older aspen forests. So that might be good news for species like pine marten or fisher. Let's take a closer look at those in a moment. I've talked a lot about aspen because it's our most abundant forest type group, and it's important for a lot of species and we manage it. But we're also concerned about many other forest type groups. We're only touching on a few here due to limited time, but I want to illustrate that the age distribution of other compositional classes, such as long-lived forests, are also important for our management decision making. So here I'm showing 3 particular forest types. One is this northern white cedar, which has its maximum area in 80 to 120 years of range. Over here on the left of this blue line is white spruce, which is in the, say, 20 to 60 year range, has its most abundance of forest. And white pine is somewhat intermediate here in the 60 to 100 year range. Now I need to point out something else here. that the total area of this is in the tens of thousands compared to the millions that we were looking at for Aspen. That poses some challenges for us because to have sufficient numbers of plots to produce viable estimates, we're starting to get down here below that comfortable level where our estimates would be precise. Jody talked about the importance of individual features and what loggers or land managers could do to leave some trees that are of large diameter or of particular importance, perhaps den trees or nest trees, as well as snags, which FIA refers to as standing dead trees. Using this FIA database, we can look at the distribution by diameter class on this x-axis of both live in blue and dead trees, which have similar distributions showing that the vast majority, almost half of live trees are in this 5 to 7 inch diameter class, which decreases rapidly in abundance out to about 19 or 21 inches, beyond which we can't see much detail in this chart. It looks like there's very little. Let's zoom in to both ends of this diameter range to look at some trends in more detail. Here showing diameters down as small as 1 inch in diameter up to 11 inch, we see an increasing trend amongst these various smaller diameter age classes. And moving to the opposite end of the diameter spectrum here, trees larger than 31 inches, we can also see perhaps a more substantial increase in relative terms. In absolute numbers, we're still looking at a small number of trees here, maybe 100,000 or 1,000,000 trees compared to billions in those various smallest diameters, but nevertheless an increasing abundance of that structural category. I mentioned Fisher and Martin earlier. Jody provided us with some interesting perspectives, something that we might use to trigger an analysis. She talked about Fisher being most abundant in their reproductive den sites in aspen, in large aspen, on average nearly 21 inches in diameter. And similarly, Martin, nearly 19 inches in diameter. So let's take a closer look at those diameter distributions here, showing all large aspen trees. This is both big tooth and trembling aspen in the state of Minnesota by these diameter classes with a 19-inch minimum. So we see a total number of 1.5 to 2 million trees of at least 19 inches. Now recall for Martin had a lower threshold, 19 to 21 inches, may provide den sites, cavities suitable for that smaller mammal species, and that comprises over half of all the trees that are larger than 19 inches, that 2-inch age or diameter class. Fisher had a larger requirement for trees, 21 inches or larger, so we can estimate about 500,000 aspen trees of that diameter class. Of course, this is just one component of their habitat. It doesn't mean that all of these trees are suitable. It just means that they have a higher likelihood of containing cavities, and those cavities could produce potential habitat components for the species. But it gives us an opportunity to assess some trends in that metric. Speaking of metrics, we haven't talked yet about the spatial patterns of forest, and we need to do that as well. As Jody pointed out, some species are forest interior species, some have more affinity to edges between forest and non-forest conditions, or of different age or type classes. Our FIA database was not designed to address questions such as these. How big is a patch? What is it next to? How far from the edge am I? It's a statistical sample that does a great job at assessing forest composition and structure. To ask these types of landscape questions, we often turn to land cover maps, or in this example, a map of forest canopy disturbance. It's based on a stack of Landsat images from which we can identify the year in which a canopy disturbance occurred and recovery to forest allows us to infer the stand age. So in the legend, we see these 4 categories, 5-year categories, just like we saw for the FIA analysis, that represent early successional forest in aggregate. One of the first things we notice is the relative lack of this across the landscape. We do see some red in various spots, but we notice that the patches appear to be quite small, with some exceptions, such as this area, the Boundary Waters Canoe Area Wilderness Blowdown of 1999. Other major disturbance events, here's one in northwestern Wisconsin. But using these land cover data, now we can conduct additional analyses to complement or augment those FIA analyses, such as this one, where we looked at the patch size of early successional deciduous forest across Minnesota, Wisconsin, and Michigan, here parsed out by BCR, which refers to bird conservation regions. BCR 12 is in the northern portion of those states, and 23 the southerly portion of those 3 states. And we identify that most of this early successional deciduous mixed forest is in patches smaller than 1 hectare or 5 hectares, quite small patches on the landscape. We can also look at metrics or indices of interior, such as this one of core area, which we define for this analysis as being at least 60 meters or 2 Landsat pixel widths away from an edge. So you're in the interior portion or the core portion of that forest patch. And we see that for the youngest stand ages, that only 5 to 10% of the area is in core area, whereas for older forests, substantially more. And that relates to older forests being in larger patches, but it's also somewhat of an artifact that this 20 plus includes many more years, so it's many more acres. Those older forests are aggregated into a single class. So there's perhaps an effect of that aggregation. This again gets to the thematic resolution or thematic scale impacts that we saw earlier. Additional work has been done in this spatial analysis and modeling project, also using some data other than FIA, in this case, aerial photo interpretation using historical photos from the 1930s, 1970s, and 1990s, and with additional work being planned to update this even further. So using this kind of data, we can see visually that the patch sizes appear to be quite different. In this case, red is upland conifer forest, and the greens are hardwood or mixed forests. We can quantify that, as has been done in this project. Slides provided by Jim Manolis of the Nature Conservancy. Thank you for providing those. And you can see that the average patch size is quite a bit smaller than it was in the 1930s. So all of this type of remote sensing, satellite imagery, aerial photography provides additional opportunities to expand on our discussion of forest attributes. So let's wrap up some of the conversation that we've had thus far and remind ourselves that FIA does provide habitat composition and structure information, but not necessarily metrics of landscape pattern. For that, we turn to land cover maps to address those questions. The status and trends in general appears to be encouraging. We have increasing area of forest land and timberland in the state. Forest type changes appear to be increasing or decreasing depending on your temporal scale. We see increasing early successional and late successional forest, but again, that thematic scale of 0 to 20 versus 0 to 5 affects our results. There's decreasing forest area in that middle successional stage or mid-aged forests. And we have increasing numbers of both small and large diameter trees. This analysis provides us a number of challenges and also opportunities. First, a reminder that this is work in progress, as I stated at the beginning of my talk, and it's an intention to understand the changes in Minnesota's forests and future implications. We'll be having more detailed conversations in October, as Eli mentioned at the introduction to this talk. So we are looking forward to further pursuing these questions. We know that changes in Minnesota forests differ among ownerships due to different management regimes, different histories, and so on. And this provides challenges when we're trying to manage for wildlife across larger areas that span multiple ownerships. How can we better coordinate those efforts? First, by analyzing the differences and then integrating our management decisions. I've pointed out several times the importance of scale on analysis results, not just spatial scale, but also temporal scale and thematic scale. So as you're asking your questions to inform your management decisions, make sure that you're asking them at the appropriate scales. Most of the results that we presented here were statewide results. For simplicity and due to time constraints, we could do this at various sub-state levels as well, such as that county map I showed earlier on. And we know that that's important because local trends may affect management decisions differently. And finally, we ask you to share your comments with us, with this Minnesota Forest Habitat Collaborative, the data analysis team in particular, if you see some errors or opportunities to further our analysis. And so in keeping with that call for feedback, I'll conclude my presentation here, and we'll have an opportunity to have some conversations now. But I encourage you to email me in the future or call me. My contact information is here, and I can relay that to the analysis team for further consideration. Eli?
Mark, thank you. Really a terrific talk, and one that I think set up the October event very well. We've got a couple of questions here online. Others who are online, feel free to submit them there, and we'll take questions here locally as well. First, a comment from Cloquet. This came in earlier in the talk. Spruce is more prevalent on public land because of tax forfeit. Oak more prevalent on private land because in South and Central Minnesota, because it's in South and Central Minnesota with less public land. You didn't get much into ownership here, but I wonder if you have any thoughts on those distributions, or if you have looked into those, or anything in response to that comment.
That is true. I cannot contradict that, and I agree. Yes, it's important, and it would be important to address sub-areas of the state. As I mentioned toward the end of my talk, that most of these results were presented statewide for simplicity, but this is a good example of why that may not be appropriate. It might not be the appropriate geographic extent or area of interest for which to produce these estimates. So perhaps if we're interested more in oak hickory, we should carve out a portion of southeastern Minnesota, some ecological unit or groupings of counties or management areas to address that question more particularly.
Thanks, Mark. Next, from the Bemidji area, interested in some FIA methodology. For example, how is the plot data extrapolated to produce acres by forest type, or such as aspen versus spruce? How is the forest type determined? That is the assimilation of forest plot data with cover type X as the dominant species. Can you talk about those processes?
Yes, I can. The last part of the question referred to dominant species, and that is in effect how we determine forest type. I mentioned both tree data and condition data. You might think of conditions on a plot as being stands or patches, the boundaries that separate one forest type or one structural stage from another. It also separates, say, different ownerships from each other. So in this case, we measure individual trees, and they're associated with a condition or a patch or a stand, and we look at the dominance. We use something like an importance value based on the numbers of trees, their species, the basal area, and an algorithm then puts those conditions into a forest type. It assigns them a forest type. And the conditions are mapped on our plots, meaning we identify what proportion of a condition is in one forest type or another, for example. And using those condition proportions, we can then produce area weighted estimates of total acres of, in this case, forest type.
There was a follow-up to that question. Which I think refers to DNR, we use average species compositions for modeling using FIA data. Sometimes I wonder if that's lost when looking at age class charts. Does Mark have any thought on that? Forest composition? Maybe it's too nuanced of a question.
Average species composition, was it the?
Yeah, we use average species compositions for modeling using FIA data. Sometimes I wonder if that's lost when looking at age class charts.
There are strengths and weaknesses to the different components of FIA's estimation procedures. For example, we just talked about estimating by forest type, and that is based on an algorithm which assigns something to, say, Aspen Birch or Oak Hickory. That doesn't mean that all of the trees are in that type. So another way that I think the listener is asking about is, can we do something based on individual tree data? And yes, we can do that. We can compute our own importance values. Say if we're particularly interested in white spruce as opposed to other spruce, or a particular oak, if it's only red oak and not white oak, we can use the individual tree data to come up with our own metrics, and perhaps that's what they're doing. FIA measures trees on plots, and perhaps the most reliable and consistent attributes we have are tree species and diameter. We have measured those consistently over many, many decades, and any analyses based on those likely are to be very consistent across time. Sometimes we change definitions, such as forest type definitions or reserved status definitions, and that may introduce some anomalies in trends. It appears that there's a big jump or a decrease in the forest type, which might simply be the result of when that definitional change occurred. So perhaps they're getting at that question. So using the most basic data of tree species and diameter and combinations of those provides you with the most flexibility and the most reliability across time.
Picking up on that idea of definitional changes, question from Cloquet: why is there no increase in forest land versus timberland after the Boundary Waters wilderness was created in the late 70s?
I'm not sure.
Kind of interesting.
I don't know that. That's a good question. We'll look into that.
Great. Moose core area, yeah, and I was actually looking at the slide as well, and I don't remember, I had something similar in my mind, and it did look to me like the amount of, maybe I misread it. I actually thought there was an increase, but yeah, we'll have to look back at that. Maybe we can report back in October. There's another question about whether an analysis like this has been done in the moose, the core habitat area for moose, and speculation, which makes a lot of sense, that kind of analysis might be useful to forest managers as they consider ways to benefit moose whose populations have been struggling with it.
There have been some analyses from grad students, from professors here at the University of Minnesota. I have contributed to some of those analyses from FIA's perspective to various folks, Ron Moen at UMD, Glenn Delgides, and others, but there are other grad students and postdocs here actively involved in that analysis process right now.
Okay, great. Another question here. Change my screen around so I can see the whole thing. Some of the slides show that Minnesota's forests lean toward smaller trees when compared to Wisconsin or Michigan. I would be curious if this is a cover type, if this is a cover type such as northern hardwoods, or site quality issue more than an age issue.
My first guess would be that it has to do with the predominance of aspen in Minnesota, which is one of our most intensively harvested or managed forest types. So if we are harvesting aspen on a shorter rotation than, say, northern hardwoods across much of northern Wisconsin, then I would expect just that age distribution of forest types to have a major impact. I'm not sure if I got to their question or not. Could you repeat that?
If not, I hope that questioner will follow up. A similar question about moose. Has anyone done this type of analysis separated by native plant community class?
Native plant community class. I'm not sure what they mean, but I can report that FIA is in the process right now of adding national vegetation classification attributes to our data. We talked a bit about forest types and how those are based on algorithms that rely on condition and tree attributes. Similarly, we produced keys or algorithms to classify forested conditions to the macro group level of the National Vegetation Classification System across the eastern United States. We're in the process of implementing those changes in our database now. So that, I don't know if that's addressing the person's question, but it will provide a new opportunity within some number of months, maybe later this fall or winter, to see those new attributes available in FIA as an alternative or a supplement to the forest type attributes that we have now. I think we have a question in the room here too.
With respect to that, how much data will we have? How far back will that go?
Right now, we're planning to do that for our annual inventory system. So for Minnesota, that begins in the year 1999, the first year the plots were collected. This key was set up to address those types of, excuse me, those conditions on annual inventory plots, that sample plot design. So in general, 1999 or 2000 across this part of the country.
Are you starting to see changes in tree species distribution in the Great Lakes with climate change?
I'm not sure about that. I know that there have been some studies that use FIA to assess potential range shifts in tree species, if that's what they're getting at. Across the eastern United States, there have been a couple studies by Woodall et al., Chris Woodall, one of my colleagues formerly in FIA, now in another research unit in the Forest Service. And in that analysis, we looked at larger diameter trees to seedlings to look for changes in the ratios of those, or relative abundance of those to one another, to see potential shifts that could be affected by changing climate patterns. If the reader or the listener were to send a question to me via email, I can point those references to them, those particular papers.
Great. Maybe we can send those out or link to those as part of our follow-up email too, Mark. So I'll try to remember to remind you about that.
Okay.
And share them with me. Another comment from Cloquet. Minnesota has twice the sampling intensity compared to Wisconsin and Michigan. Does this pose challenges?
Or opportunities. So what the listener is referring to is the sample design is that we establish one permanent plot for every 6,000 acres or 2,400 hectares approximately across the entire state of Minnesota. That's referred to as our base federal sample intensity, one plot per 6,000 acres. Minnesota Department of Natural Resources contributes additional funding to double that intensity. So now we have one plot for every 3,000 acres. And that allows us to produce more precise estimates, or put another way, we can produce estimates over smaller areas of interest, smaller geographic extents. Other states may have fewer or more plots. I believe that Wisconsin also has double intensity, Iowa single intensity, Michigan is currently single intensity, but was at one time triple intensity. So having less or more in your sample affects the precision of your estimates, but it doesn't affect the way the estimates are produced. The estimates should be very similar depending on how many plots you have, but the variance, the uncertainty of those estimates will vary with the number of observations in your sample.
All right. I think that brings us to the end of our questions online. Are there any others locally here? Okay. Well, in that case, I want to thank Mark for a great presentation. This has been terrific. I will remind folks that so I'll stand up to do it. The event in October will be.
Do you want to speak to the camera here?
Yeah, I'll come over. The event in October, so today's presentation was kind of a precursor and an opportunity to go deep on some of the data. The event in October, the 10th and 11th in Grand Rapids will go along that spectrum that Mark opened with from Jody's slides, starting with kind of the landscape and region scale with a short summary of some similar data, not maybe exactly the same as what we heard today from Mark, along with several others presenters talking about relationships between forest management and wildlife habitat outcomes at a variety of scales and in a variety of ways, including silviculture, including outreach and continuing education to landowners and land managers, and just a whole variety of different things. So I hope you've enjoyed the presentation and found it productive. I will share a link to the October event in our follow-up email, along with the resources that Mark mentioned and some other things that came up during the talk today. And I think I'll bring us to a close. Let's thank Mark Nelson for his talk today.
Thank you.